Okay, so let's see what is on the docket for today. Load up current review board. And that's taking a long time. While we're doing that, I'll make sure we got everything up to date. Let's see. Let's update with current master. Okay. All right. So yesterday I submitted a patch to add some tests for BOpenHashTable because there may be some issues with that data structure that need to be addressed. So I decided to bring it under test before making any changes to it. So it looks like Polkomandy has some reply. Okay. Oh, you know, that's a good point, actually. He's pointing out here that in these tests, I had heap allocated the entries that go into the hash table. When, you know, he's right, that's really not necessary. I could have allocated on the stack, so that is an easy change. Oh, he's also right. B-list, you know, B-object list, I haven't actually used that data structure before. So I guess we'll learn how to use it. And then, let's see. Entry value. What does he mean here? Check map and entry value. Well, I guess what he means is that that seems harder to understand, frankly, than what's here, because basically this test is creating 20 items and then adding each one to the table, the hash table, and then using the iterator to verify that it can actually read those out. And it's verifying by saying that the total number that it gets from this iterator is the same as what count elements returns, because we increment count on each iteration here. And then the other thing it verifies is that the sum of all the values is equal to 45. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 19 sums up to 45. So for some reason he's saying that we do this instead. I'm not totally sure I understand the benefit, because honestly that seems harder to understand. Oh, but he did point out a problem here. Looks like we have a bug. He's probably right. This macro might be easier. I was following the example of using this check macro, but really this might be better. So we'll look at why that is. Oh, and he's pointing out that this comment is wrong. Yeah, because I said 10. Okay. No big deal. Okay, so let's fix these one by one. So first, I think let's just replace that check with this CPP unit assert equal. That should be pretty easy. So we got this. We'll check out this branch again, and let's open up that test file. What is it called? BOpenHashTable. Okay, so first, I think that means we probably don't need this test utils header, because I think this is what we're using for that check macro. So let's replace this with this macro he was talking about. So I think the difference here is that this doesn't take an expression. This takes a two expressions that it compares equality with. So it takes two arguments. So let's replace this. So this is going to be all of them. I'm just doing this one at a time to make sure I don't accidentally replace one of them inappropriately. Okay, let's look at the definition of this. We don't have it indexed for some reason. Okay, so then the next thing is that we need to replace that equality with, I believe, let's see, let's look at other examples here. Because I think this, yeah, so it expects expected and then actual. Okay, so this will be better. He's right that this is like, will actually be easier to understand. So, there we go, yes, yes, yes. This is exciting, right? Okay. All right, so those are all replaced. So let's make sure we didn't break anything here. So we'll build the unit tests. And while we're waiting for that, let's look at the next thing on the list. Oh, though actually the next thing is we need to do here. So this was wrong. And we did it here too. So let's start this one more time. So now we're checking, now we're using this macro, so that means that that bug we had before shouldn't be possible anymore, where we just had the equals instead of double equals for comparison. And it was not declared in the scope. So where is this declared? We grepped for it earlier. Looks like it's in test assert. So we want and then let's sort these. Okay. Let's try that again. So now we should get and like Pocomandy said, the nice benefit of using requires two arguments, but only gave one. Looks like we messed up. Oh, I see. So is there a not equal? Looks like I don't think there's a not equal. Which is a shame, but that's fine. We can change this to be just CPP unit assert, and then here too. Oops. Looks like we did it here too. Okay, I think that's all of them. That's good. So Oh, whoa, whoa, oh, nope, that's not what I wanted to do. So one of the reasons why I'm working on this is because there is a bug that I found that I ran into that had been reported. Let's see. I'll pull it up while we're waiting here. In this TCP protocol add-on, the problem is that this BOpenHashTable is used for, I'm not going to log in for now. Let's see, timeline. It is used to keep track of open connections. And part of the problem is that this, it's this ticket right here. So part of the problem with this particular add-on is that, or actually any use of BOpenHashTable is that it's possible to use it incorrectly. So this hash table doesn't actually support duplicate entries being inserted. It actually leads to a cycle in the linked list that is in each bucket in the hash table. So I brought this under test for this particular patch in order to potentially make some changes to this to make this hash table a little easier to use correctly. And we can talk about that more in a bit. For now, let's run the test to make sure we didn't break anything. And it looks like we did break something. 190. Iterate. Where is it? Iterate and count test. Here we go. So it's saying that all of a sudden, oh, you know what? It looks like I summed this up wrong because I added up the sum up to 10 items, but not 20 items. So let's verify that really quick. So 0, how do you do this? Sum of n for n in range 0, 10 is 45. So that's the problem. I originally said this was 10 items and I changed it to 20. So this is actually 190. Good. So now that we're switching to this macro, we're actually realizing that this is not correct at all. So that's good. Okay. So that should fix that. And then I think we did this one other time. So this is 190. And then 20 elements. Yeah, I think that's good. So let's try that one more time. So yeah, the big problem with BOpenHashTable is that, well, let's see. Okay, so the big problem with BOpenHashTable is that the way it works is that you tell it that you're going to use entry in this example as the item that goes into the hash table, and then you define this entry definition, and this is how you tell the hash table how to reason about each object. So it tells it how to hash the object, how to hash a key, and how to take the object itself and hash to that key. And you define what the key and the entry and the value type are. And then you're required to implement a function for comparison. And then getLink here is the intrusive linked list part. So this is how you tell. So a hash table, right, is usually you have some set of keys that you have a space of keys, and each key you hash it and get a value out of the hash function, and then you use that value in order to tell which bucket to insert the object into. Let me open the thing in question here. Here, private kernel util. I think this was it. So in insert, we'll see what I'm talking about here. So this insertion function. Yeah, so it calls the hash function to figure out what the hash of the value is. This is the definition that was provided. And then it takes the, basically this is the equivalent of like modulus table size, so that the index you get is within the size of the table. And then it takes the head, the item that you're inserting, and makes it the new head of the linked list. So here, this is the head of the list currently, and we get the calling link calls this getLink method on our definition, which basically takes the intrusive next pointer from our object in the hash table. So this basically, and then we set that as the head. So we're basically inserting onto the beginning of the linked list. That's a problem, of course, when you have, if you insert the same value twice. So if I insert the same value twice, then you basically have the head and the next item, which are the same object, pointing to each other. Now you have a loop. There are ways to deal with that, of course, but they have cost associated with them. So, for example, this, before the thing that calls this is resize, so that's not what we want. We want the caller here, which is insert unchecked. So this one has this check duplicates flag. So this is a non-type template parameter, which defaults to false. But if you set it to true, then it's essentially scanning the linked list at the bucket that owns this object in the hash table, which is kind of unfortunate, because that means that if you trade off here with this design safety for runtime costs, because insertion goes from constant time O of 1 to O of n, because you essentially, in order to insert, you have to scan the whole linked list to find any potential duplicates. So there are design changes we can make to this to make it easier to use, but we'll do that in a follow-up. For now, let's just focus on making these tests right so that we have something to compare against when we change the implementation. So let's see. Now, test pass, good. So let's just review that change to make sure that it's correct. Okay, so we have, we added test assert. We have changed all of the check macro usages to CPP units are equal. Good, okay. So let's just commit that for now, and then we'll rebase in a minute. Oops. My editor did not have its little server running. Okay, so switch to unit. So equal. Okay. Now let's look at the next one. So the next one is that Pokemon is right. We do not need to allocate these on the heap. So let's change that. That'll be easy. So here, we just need to, and then when we actually insert the item, take the address of it. Okay, that's much better. So let's look at the other ones. Those ones use, basically all the ones that only have 1 or 2 entries and don't currently use a vector to store them. We can make that change really easily. Okay, and this works fine because the BOpenHashTable doesn't take ownership of the object. So it will never call free, so we can safely pass the address of something allocated on the stack. And did I miss one? Yeah, I missed this. And here. So you can see, by the way, that this duplicate insertion test checks the behavior I was describing before. So it actually we're defining the entry table as using entry definition, check duplicates, and always expand. Maybe it's the other order, I forget, but that means that after we insert the first one, the second time we insert anything, it's going to trap in the debugger, because that's what that check duplicates flag does. Not super useful. It actually is pretty annoying to use, right? Because you're basically trading off safety, but you crash essentially, or not really safe and potentially fast, but you can introduce a link cycle that leads to safety issues. Okay, so that is almost right. We just need a couple more of these. We may have missed one, but we'll catch it the other way around. Okay, now here we can do the same thing. Oh, it looks like I missed this object deleter. And then this is entry 1, and then entry 2, and then we want to okay, so that should be right. And then here, same thing. Okay, now that I think maybe all of them, yeah. Okay, so this one we don't need to change at all, because in this case we're essentially passing ownership of this object that we're dynamically allocating on the heap to this container, this BOpenHashTable, and then we are calling clear elements here and telling it to return the head of the list, so that then we can delete it later. So this one I think is fine. We don't need to change this one. Let's see if we broke anything. Yeah, we did. Let's see. And 210. So we can take the address here, and then miss any other ones? 210. That might be the only one. Oh, we missed one here too. 204. Oh yeah, because we didn't delete that object deleter. And then 198. We're checking. Should return the address of. It looks like it. So let's try that again. Okay, and last problem here. Here, yep, one more time we missed it. Okay, so let's run the tests. Looks like they pass. Good. And so this time what do we do? Oh, right. Use stack out possible. Okay. Now, the next thing Okay, so we've done this. And then instead of vector, we can use BObjectList. Okay, so let's figure out how to use that. First, let's just get rid of vector here, because we don't need that. No entry for BObjectList. Let's look at the bbook. This may actually be a problem if BObjectList is in libb, because we don't actually link with that in this. No, that's not what I want. Let's called object list. Yeah, here we go. Okay, so it's a template. Object list is a wraparound B-list that adds type safety optional object ownership. Okay, so here's the ownership part. So that means that I'm anticipating that means that if we tell it owns the object, then it will free that object. Okay, so here's the definition: BObject list of T, BObject list owning false. So if owning is set to true, then that should be. Let's see what that does. Pointer list. Pointer list owning. Okay, so then we should make empty if owning and delete if owning. What is delete? Oh, delete if owning. I see. Well, let's look at the destructor. We want this here, pointer list. Oh, that didn't work. Where is the destructor? Here. It's empty by design. Owning variable is used by BObject list subclass. Okay. So that means that here BObject list. So, man, my editor is really not doing the right thing. Here we go. So if owning, make empty. And then delete if owning is probably a default parameter that's set to true. Yeah, okay. So if we set owning is true, then that means that it will delete the object. So how do we use this? Looks like we give it, so that's a copy constructor, items per block, owning. I really just want a okay, so we can just say 20 and true. So okay, that's good. So that seems pretty simple. So, but what is that defined in? This is object list support. So okay, OS support object list. Here, instead of object deleter entry, we make it the object list of entries, and we say, let's say 20 and true. So 20 items per block, and then true, this should be owning. So then, instead of this entries set to, because we don't have the vector anymore, vector of object deleters, we call entries dot add item. Okay. What is the second parameter? I'm curious. Oh, this adds to a specific index. So we don't care about that. We're just adding it in any order. Okay. So we want to add item entry. And all right, that should be it. Let's try that. It didn't work. What's the problem? Oh, this is a problem. So I think if we use BObjectList, we might have to link with libb. Let me verify that. I don't know if we actually want to link with libb here, because this code is used. Well, that might be all right, actually. Yeah, I don't see a problem with that. Yeah, so that was the problem. We just need to link with libb. And I don't see a problem with requiring these tests to link with libb. They obviously don't have that dependency for the actual implementations because they're used in the kernel. But some of the data structures here. But that's okay for the test, I think. All right. So what's the other vector? Here. Okay, again, the object list of entry. And then add item entry. And one more. Let's give that a quick spin just to make sure that we didn't miss anything. Looking good. So that leaves, I believe, one last thing. So I think we've gotten all of the problems that he pointed out here. So stack allocated, yes. We use BObjectList. We haven't addressed this. Okay, we fixed this problem. We switched to CPP unit. We fixed this comment that was wrong. And we fixed this. And that's it. Okay, so this last suggestion, let's try to understand what he means here. I would use map. What is map? What does he mean by map? Map and entry value. Oh. I think I see what he means. I think he would say, he means okay, you know, I think we should just ask a follow-up because I'm not entirely sure I understand what he means. For now, let's update this. Okay, so okay, that looks good. Now let's rebase. faster. And we'll just squash this together into one change. And we'll say, I guess we'll just keep the same commit message, but we'll add some notes here. So let's see, we say making So let's push these changes. I'm not logged in here. I think I'll just switch screens to a computer where I am logged in. There we go. So while that's pushing, let's go to, actually, have it open right here. So let's refresh. Okay, that's pushed. So I should see this new change set pushed here. Yeah, there it is. So let's see. I always forget how to use this thing. Oh, actually, we missed something. What did he say here? Keep 2 blank lines here. Ah, dang, we missed the formatting thing. You know, I used the check style script, but didn't actually catch this. I think that's what he's referring to. Oh no, he's talking about. He's talking about one that I didn't change here, but I think that's also correct. He means here. Okay. So let's rebase one more time. It's funny, you know, I'm not really that used to using Garrett. I haven't used it much outside of the Haiku project, so I'm a little puzzled sometimes as to like how I'm actually supposed to reply to these things. But this is probably it. Usually there's an ACK button, and I'm not seeing it. Unresolved threads. Am I not logged in? Oh, I'm not logged in. That is why. That explains it. Okay, there we go. Okay, so we've done this. We've done this. We've done this. I think I'm just going to say and then we'll submit this, and then that'll be that for this.